Okay, and we're back. We just finished talking about governors. Now you're governor experts.
Yeah.
What kind of prop is this?
Counterweighted.
It is counterweight.
It is a
Two-bladed.
Hamilton Standard.
Two-speed.
Two. You're wrong. It's a Hamilton Standard
Constant speed.
constant speed prop. What's the difference? I just made it constant speed. What's the difference? Take away that little valve that goes high pitch, low pitch, and put a governor on. Ta-da. Ta-da. There we go. Well, you want to see how smart you guys are? What kind of bolt is that? What's inside of it? Look how smart you guys are.
That was pretty good.
All right? All right. Is this in high pitch or low pitch?
Low.
Low pitch. Should you store it this way?
No.
Damn, look at you guys, man. There's actual hope for you. All right, what's under this cap right here?
Adjustment screw.
The stops.
Your stops.
Damn near experts.
With the numbers.
All right. What's that hole for? Actually, what's that hole for right there? Cotter pin. Cotter pin goes through there. Comes all the way through, goes to the other side. What's a cotter pin for? Keeps the thing from unscrewing.
That's the truth.
Okay, how about that hole?
Safety wire.
It's actually it's a lock ring that goes in there that puts through the pins, but you got the idea. All right, very good. Well, how's it work? Remember this?
Take the governor, take the prop from the other.
No. That's the wrong. Just one.
It's the wrong picture?
That's the big show.
It's the right picture.
That's right.
It's the right picture, but I got notes all over it because I hate the drawing. This is what I was complaining about the other day. The prop is in low pitch, high RPM position. It is in that position. In the low pitch, high RPM position, more of the piston's exposed to the elements. See how that piston's exposed right there?
Yep.
Talked about that, right? Okay. Arrow show direction prop needs to move to achieve the on-speed condition. So we're saying on this one, okay, because you know about the ham standard prop. Now I want a ham sandwich. You know about this prop. Now we've just taken off that valve that made it a two position, and we've added a governor, and it's going to work just like it should. So we have a governor on the top that is going to sense on speed, overspeed, underspeed. Right now it's telling us that this is an overspeed condition. So the flyweights are out, overspeed condition. I expect when you guys take your test on this, when I look out there, I see a whole bunch of this stuff.
Yeah.
Right? Yeah, I have this piece of scratch paper, and the first thing I do is I write, this, and this on it, and I make all my notes. All right. So it is in an overspeed. So the flyweights are out. It is a counterweighted propeller. Therefore, if it's in an overspeed, it needs a higher pitch. What's going to do it? Centrifugal twisting motion or oil pressure? So we got to? We got to drain. All right, so that's exactly what this is showing then. So we got to move this piston dome. I'd rather stand at the board. We got to move this piston dome right here backwards. It has to go back that way. And how are we going to do that? We're going to drain oil. So it's going to come up through here. We went into an overspeed. It's going to lift up the pilot valve, opening up a drain line that is going to bring it and just drain it right out. Overboard, yes. So it's going to go right back into, this is the engine case. Obviously it just drips down in the engine. I think there's little drippies right there. And there it goes. Not a problem, right? Okay, now we go into underspeed. Prop is it is in the high pitch, low RPM position. Note the piston remains stationary while the cylinder moves. So it's this outer piece that moves, inner piece stays. It needs to. So we are going to an underspeed. So
Flyweights in.
flyweights in.
Valve
Valve drops out. engine oil pressure that has been coming through here, going around the gears, around the outside, now has a way to come down, feed through here into the transfer collar through the middle of the crankshaft, push on this and start pushing this forward, bringing this back to lower pitch. All right, that's the ham standard. Now I'm going to talk about the more conventional propellers. It would be really easy, and I think I've done this to my students, to make it more difficult than it needs to be. Honestly, at this point, there's nothing really left to it. There's Macaulay and Hartzell propellers. Macaulay propellers and Hartzell propellers work exactly the same way as everything we just looked at. There's nothing different. The major difference between a Macaulay and a Hartzell is the sticker on the there's a little bit more to do that, yeah. And you can tell this one's a Macaulay because it says Macaulay on it. They do have different hub designs. We'll look at a little bit of the hub designs and get stuff on that. But don't get lost with, like right here, I've got the C200, the 300, the 400. It's just like, hey, you can look at it right now and go, oh, that's interesting. And then don't worry about it. All right, I'll kind of lead you along what's interesting. So this is typical of the one I have on my plane. Reciprocated, two types, constant speed or constant speed feathering. So constant speed would be single engine, feathering goes on the twin. Okay. Let's see, 200 is two blade constant, 300 two blade constant feathering, three blade constant. Okay, see? Oh, wasn't that? Oh, that's, okay, really cool. All right, got it. The Macaulay propeller. All right, is this feathering or non-feathering? See, I mean, you guys are just picking it up. It's really easy to do. Non-feathering. All right, let's zoom in. Wait a minute. Before I zoom in, let me see. No. I'll zoom in here. I'll zoom over there. So oil is going to come up through the crankshaft in the middle, through a transfer collar, up through here, out these little holes, and fill this area right here. See, we got an O-ring right there, and this dome. So when I add oil pressure up here, it is going to push this down. It is going to push on the, and this, I cannot figure this out for the life of me. Why? This is phenolic. Phenolic is a, I don't know how to say, it's like a plastic. It's an insulating material. I don't know what it's really made out of, but it's a plastic. And why they use a plastic, I cannot begin to tell you.
So it was made out of like oils and stuff.
What's that?
Out of like oils.
Yeah, it is. Yeah, but it's not plastic, but it's the properties of wood and plastic almost, somewhere in between the two. Okay, so it's going to push down on this, which pushes on the pin. The pin then rotates the propeller, which is crazy. That's just plastic. You might want to write this down. There are a couple of types of Macaulay hubs. There's the old style, which is threaded. Threaded equals bad. And there's the new type, threadless. Threadless is good. So the old style had these gigantic thread. This is a threadless. You can't. There aren't any threads right here in this orange area, and you see a snap ring holding it in. Let's see if I can get this picture. This is the threaded type. See the big threads? They tended to crack because whenever you have threads like that, it creates stress risers in the little corners, and they would crack. You see that's that little phenolic piece right there. So we can do a little bit more digesting on this. So it does not have counterweights. This is all stuff you already know. Does not have counterweights. So what moves it to low blade angle? Centrifugal twisting force. What do you see inside? A spring. So what do you think the spring does? Looks like it's pushing this forward. So on an oral, on something like this propeller, it's not very hard. I would say, what moves it to low pitch, high RPM? And you would say centrifugal twisting force and a spring assist. I'll say awesome. Is this threaded or threadless? And you would say threaded. And I would say, is that the good one or the bad one? You would say it's a bad one. It's one. I wouldn't prefer that one. And I would say, okay, what moves it to high pitched, low RPM? And you would say engine oil pressure off of the governor. This is not hard. Okay. You cannot adjust the pitch stops in this one. Okay, remember there's high pitch stops and low pitch stops. That's done at a prop shop. And it has something to do with the way the shims go, not this shim here, but shims back inside the hub. We cannot open these up. I mean, you can't here at school. I don't care. I've got some if you really want to. But out in the field, we do not open them up. Another question. What is inside of the Macaulay hub? Well, we have oil up here, but not necessarily in here. Do we have engine oil? So Macaulay is going to do one of two things. And I don't fully understand this completely. One type of prop, they will fill this full of engine oil or an oil with a red dye. So you're going to want to write that down because I'm going to ask you that. So Macaulay prop is filled with oil with a red dye. What is the red dye there for?
Leak detection.
It is a non-destructive testing. When you see a red dye seeping out, you don't go flying.
That's right.
You get out your checkbook.
Red means bad.
You call your home equity line of credit people because you're about to buy a new prop. Macaulay does talk in one of their manuals about there is a type of hub that does not seem to have this, and it has a spiral lock, which appears to be a very small hole drilled through it for a vent. And that's the part I don't fully understand. Well, you can't vent it and have it full of oil at the same time, so I don't know. But anyway, how do you adjust the high pitch and low pitch stops to this particular?
You don't?
You don't. What's it filled with in the middle? Oil with?
Red dye.
How can you be absolutely certain that it has the red dye oil in it?
Take it apart.
Huh?
Would it be on the sticker?
My man,
Sticker.
look at the sticker.
There you go.
Prop shops kind of view the rest of us, as they should, prop idiots. And so they don't even trust us to look in the book. They just put stickers on it.
That's nice.
They must trust us a little bit because it doesn't say no touchy, but okay. Right here, what is that? It's a weight. So that's a balance weight. So if you see little weights like that, they're balance weights. Okay, let's talk about balance. We talked about balance, right? So there's static balance, which is you take it off the airplane, put it on a balance machine. We have one, and it used to be a project, but it just seemed like it frustrated people because you just take a prop that's out of balance and you put a bunch of weight on it until it finally stops moving. Like, oh, now what do you want me to do? I'm like, nah, so it's one. I just don't make you do it. So you have vertical balance and horizontal balance. So that's usually done at the prop shop. Remember, there is dry balance and wet balance. So dry balance is no grease. Wet is
With grease.
okay. How do you grease this prop? This is my favorite one to grease. You don't. It's permanently sealed. Now, prop shops have limits, and they say, well, you should probably send it in to us to have it taken apart, checked for corrosion, sealed, and re-oiled every 5 years. Which is another way of saying, hey, you should buy a new prop every 5 years. So. All right, another Macaulay. Let's see here.
Without threaded. Right?
While I'm at this, I can talk about that. That is the worst safety job you will ever run into in your life. And I've done some difficult safety wire. This is it. This is a stud with a castellated nut with a lock pin going through it.
What?
So they made it into a bolt. It's the only way you can assemble it because you can't get the bolt in that hole. So they had to make it a bolt as it went. Can you follow? You see the little, so it's a castellated nut with a roll pin, making it into a bolt. To safety that, you put the safety wire through the roll pin, out this other side that you can't even get to. And then you have to wrap this around that side and then tie it back in there that you can't get to. Roll it up around this one, and then it would have to come through this one, back around that one that you can't even see, tied off and out with 040.
Jesus.
Now, somebody did say once that somewhere there's a service instruction that says you can use 032, but I'll tell you right now, so few people know about it. If you ever used 032, they'd probably go, oh, you idiot, you used the wrong stuff.
Is safety cable not allowed on something like that?
I don't know if you can get it in there.
Just join
All right, so the hub has what in it?
Red dye.
Yeah, and there's a sticker.
And the sticker too.
What's the part number Bravo 7366? What is that?
The oil.
The red dye.
That's the part number of the sticker.
Shut up.
No, it's part number sticker.
No way.
Yes, way.
No.
Everything.
Really?
Even the
Yeah, part number says stickers on it. Yeah,
That's
it's-
cool.
Yeah, it's an official sticker. You can't just make it up. Okay, so you got red dye leaking out right there. That is very expensive. Okay.
That too.
All right, so there we go. We've got our actuating pin, our spring, our hub. Let's see, low spacer, low pitch. There's, I told you, they're internal spacer, support, piston, high pitch stop back over here. So it's just that piston is going to hit the low pitch, high pitch stops. All right, 200, 300. I forget. One day I just had, I'm going to put all this in here, and this would be a great idea. That's not a great idea. Okay. One way to tell the difference between a feathering propeller and a non-feathering propeller is counterweights. All right. So two things. One, counterweights. But maybe not always, because in my mind, there's some propeller out there that doesn't have counterweights, and it uses air pressure and spring pressure, and it may not have counterweights. I don't know what brand or it, but let's just say that exists. Then there's something else that's a dead giveaway. Look at the size of the dome on this.
Small.
Very small, because it goes on a single engine plane. It's only a couple of degrees at all that it ever moves. It's surprisingly small. I'm always, even me, I fly one and I'm thinking, it must move about that much. Yeah, it moves about that much. And that much movement makes a lot of noise. All right, go into a feathering prop. Okay? Because it's going to move instead of this.
It's gonna go
Yeah.
all the way.
It's moving almost 90 degrees. Okay? So you see that dome up there, and it's a big old dome? That's feathering. Feathering, okay. Turbine engine props. I don't know how to get into that. Not right now. Okay. So that's Macaulay. Macaulay's pretty, they're about all the same. You got the two hubs, you got the thread and the threadless. They look nearly identical. They're hard to tell the difference. You got to look at the end plate and see if it's got snap rings or it's got something that'll unscrew out. All right, then we get into the Hartzell. So Hartzell has two main styles of propellers: the compact and the steel hub and compact. Let's see. These pictures they're not quite right. This is the compact that looks fatter and bigger, and the steel, which looks smaller. And so, I guess you could think of it this way: it's compact because almost everything is compacted into the hub. Okay. So if I look at this one, I've got big old counterweights back there. I got rods. I'm pretty sure this one is the steel hub, but then that looks like it's not right there, so I'm not 100% certain. We'll come back around to that one. All right, there we go. Definitely a compact. So I got a compact. Is this off of a twin or off of a single? Why is it off a twin?
It has blades and the big old dome.
Well, that's blades. They all do.
Counterweight.
Counterweights
Big
and
old dome.
big old dome. Okay. There we go. Same way, Joe. Let me see. Find something meaningful here. Nope. Okay. Forgot about that one. Now it's fun to talk about. All right. This particular prop I have a movie on this one, so a video. That, well, actually, it's pretty good. I like it. And the thing I like about it, I'll tell you right now, is the guy who does the video is not an actor. They went to Hartzell one day to do a video, and they're like, our actor didn't show up or something. The guy's like, well, I guess I'll do it. He's an actual technician. So give him some slack. His acting skills suck. All right, so this one, we see a very large spring and Schrader valve. So this is going to use air pressure and spring as one force.
And oil pressure is the
Well, I should say air pressure, spring, oil pressure, and centrifugal twisting force as another. I should probably be looking at some of my notes here. I'm probably telling you the right information. All right, that's a good one to write. Okay, so for our, I'll back up a little bit. We had our two props, be more definitive about something. Steel hub and the Hartzell. So steel hub has exposed operating mechanism. So steel. Exposed operating mechanism. And compact has no exposed operating mechanism. Okay, I don't have a good pitch for compacts. We'll talk about the compact a little bit. Number one, up here, you get to set the low pitch adjustment. So when I ask you about, hey, what's this screw do up here? That's your low pitch stop up there. So you can adjust that. So if you weren't able to achieve full RPM in the aircraft, I wouldn't just go out and adjust this thing. But use the manual, set it up to what you're supposed to. But if you weren't able to achieve your full RPM, you can adjust this up here. It's a little lock nut with that shows as a bolt, but it's not. It's an internal wrenching screw. You can adjust that and change your low pitch stops.
You say that was on the steel one or the
Compact. 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 Thing I don't like about the compact, number one, you're responsible to make sure it's set up right. It's a Macaulay, it's like, what do you want me to do? All right, now you have responsibility there. Number two, has grease fittings. It has more than just one. It has several. 4, I believe, on the newer ones. 1, 2, 3, 4 on the other side. You can't see them. And I'll show you in the video. This is where people screw up. You have to be very careful. Number one, what grease should you use?
Sticker things.
Whatever's on the sticker, which would be about right there. It'll say use such and such grease. Number two, how much grease do you put in? It's changed over the years. Very little is the answer. 4 pumps, about 1 ounce, I believe, is the right amount. And you have to be careful about how often you do it because the prop only holds so much grease. So consider, if somebody flew a few hours every year and it came in for an annual, I'd not grease it every single year. We consider that. You have to take 1 grease zerk out for a vent. And there's a specific one you take out. I reference the manual when I do it. I don't do them enough that I have this memorized. And so you take one side out. Let's say it's the trailing edge I think you take out. But you take out, let's just say it's like either the trailing edge or the leading edge. We take, say, trailing edge out, and you pump in a few ounces of grease, and that is it. I was listening to a podcast where somebody talked about how she just greased her prop, and I just pumped it in until it came out the other side. Like, don't do that. So it does say in the book, like 1 ounce or until it comes out the other side. It is whichever is first, not whichever's last. Yeah.
For greasing it,
Yeah.
would you look in the logbook first to see what the last grease was used? And
You
then-
should do everything you can to verify. So look at the sticker, then open the logbook, see if anybody said anything. And if the two didn't match, I'd be like, oh gosh. Now you have to call the customer and you have to say, look, I had a problem. All right? You're supposed to have this grease. Last guy did it, put this in. They're intermingled. I guess you'd call the prop shop first, ask them if they're compatible. If they're not, then you call the customer and say they're not compatible. Prop shop said this is a bad thing. Prop shop said you should do this. Blame them. What do you want to do?
That's how you do it.
And they say, well, just you can leave it. It'll be fine. Now you got a different problem on your hands. So,
If they're not compatible, do they like react under the heat, causing more corrosion, or?
I don't really know. I'm not a chemical engineer guy.
And some like you have calcium and lithium based greases and stuff, they don't like each other, they'll cause it, both of them to break down.
Yeah, you can have a whole bunch of things.
All right.
So just
Oh yeah, located nearest the leading edge of the blade on the tractor. Blade angle. And we got that. Let me see. All right, on the compact, we'll call it the counterweighted prop. Counterweighted prop. What does that mean? Now it's counterweighted. Counterweighted also means usually feathering. Counterweighted feathering compact. We've got air pressure. Air pressure and counterweights to move to what? Feather. Feather / high pitch. All right, so how much air pressure do you put in there?
It's on the sticker.
It's on the sticker. Are you seeing a theme here? Find a sticker. See if I have a sticker here. Oh yeah, I already looked at all these. Okay, I saw it. Right. So on these type of props, the spinner comes like this and down and around and like that. And then on the outside, I love this, you've got another spinner. It just goes right there, a little cone right there. You can take that right off. And you take that off, and you're going to see your Schrader valve. It's called a Schrader valve. And there'll be a sticker right in here somewhere that says how much air pressure to put in there, at what temperature. So you look at the temperature, and you put in the right amount of air pressure. Now, the way this, you should use nitrogen too, because air has moisture in it. You can start corroding things, so I'd recommend nitrogen. The way this usually works is you get a calibrated air pressure gauge, and you walk up to it, and you try and put it on, and you leak out most of the air, but by the time you finally get it on and stop leaking, you look at it and you go, yeah, it needs a little bit of air. Probably would have been perfect if I wouldn't have touched it. Then you got to service it, so be careful with that.
Cha-ching.
Air pressure in there is about 150 psi. Well, what's the pressure of a governor? About 250, 275. Not always. I had a really bad experience with an engine. It was one of my worst stories, horror stories. Now you want to hear it. So the shop I worked at, we built radial engines. And so I had built several under the guy who retired and had no problems with the Continental 220s. But we had some customer with a Cessna 195 or 190, 195. It depends on which engine. It's a old. It's a tail wheel Cessna with a cantilever wing. They're really cool looking. I hate them now because of the story. It's a lengthy story. Cessna 195. Yeah, they're pretty cool looking planes, huh?
That is,
It's not that bad. It wasn't that plane for sure, but all right. So they are cool.
it's classic.
Yeah, they're pretty classy. Anyway, well, yeah, trade a plane.
Oh, that's
Cheap
it?
too, apparently.
That's it?
Yeah. So what's this one here?
Just refund.
1953. You got that? Which engine does he have in there? They usually have the Jacobs now. Jacobs, yeah. So Jacobs, I think that's what makes it the 195, and the 190 I think had the this Continental, which is incredibly rare. I've only seen one in my life, and it was this one. Never seen one before. So it's just like the 220, but it's a 240. So all right, so it's very similar to the engines that we've been overhauling. Difference is this one had a constant speed prop. So guy brings in, instead of 220 horsepower, it's 240, so it had higher compression pistons. So brought it in, overhauled it, but taking it apart, the transfer collar to transfer the oil from the governor up through the front, it was a stack of brass rings like this. I mean, there's all these rings in there. I'm like, oh my gosh. So, I called an expert on this. I'm like, okay, so what, how do I deal with these rings? Everything else I got down pat. And he's like, okay, don't mess with them. They're irreplaceable. If you break one, you're done. Don't do anything. You take them off, keep them in the same order, wipe them clean, set them aside, then you put them back in. That's the overhaul procedure. Don't mess with them. Okay. So, got the engine together, and honestly, I made a mistake and missed a plug. There's so much on the radial. And so didn't get proper lubrication to the top end, but I figured it out right away. So I'm like, okay. So I just took the cylinders back off, inspected and cleaned everything, made sure it was all okay. Ran the engine, tested it, everything was fine. I don't know, the story goes in and out of stuff, but the guy brought it to us because he was flying along. He heard a loud bang, and he said, I swear to you, the prop stopped for a second and then started going again. And it caused a crack through several of the cases, because it's a radial. You've got power section, nose section. All right, the thing has been around since the 50s. The metal is fatigued. So it got sent out. It got weld repaired. It was just a whole bunch of bad things happened. And the funny thing was, so we trucked it back to the guy. He put it on his airplane. Then he called up, said, you screwed everything up. The whole engine's wrong. I'm like, why is that? It's leaking oil everywhere. I'm like, oh my God, I don't know. So I drove all the way down a long way to this airport to see what was happening. Well, his mechanics, who knew absolutely everything, and told him that we screwed up the engine, put the prop on wrong. He had one of those Hamilton standards. So you got to put the lock collar on, then you have to put the hub on, you have to have the seals. He didn't do it right. So when it started up, it shot oil into the dome, just like it's supposed to, and out the prop blades, and just doused his engine. And I forget what happened. It was so long ago. But he had finally cleaned the whole plane. It was spotless. And I show up, and we started it up again, and it just doused the plane full of oil again. And that was good for you, jerk. So when I finished building the engine, they were in a real big hurry to get it. And we had the prop governor, and we had to send it out for an overhaul because we had the prop governors. And the customer said, I will get it done myself. Just give me the prop governor. So he had the prop governor overhauled. His guys who knew everything put it on the engine, and away it went. Well, something happened, and it developed a small crack up in the case again because the metal's fatigued. So his guys who knew everything took the engine apart on their own, and every one of those transfer collar rings had worn down to a razor blade. You couldn't even touch them; they were so sharp. And so I'm like, wow. So I called the guy who was giving me advice, and I said, what happened? He goes, oh, that's simple. Prop governor was set to standard pressures. You can only set these things to like 100 PSI. He goes, you go to 250 like that, it'll eat those things up in like 4 hours. So he wanted to sue my company, and my boss said, the F you will. And that was the end of that. So he bought a Jacobs and made it into 195. So he wanted one anyway. So. That was just a whole. There was even worse stuff that happened with that. It's just, he asked us to do stuff. We agreed. Then he used it against us and all kinds of dumb stuff. But anyway, so I don't like that airplane. So there was a point to that story. Yeah. So the point to that story is be careful with your pressure on your governors. All right. Let's see. Thing about these props with air pressure up front, now you got one more thing to deal with. So you got to deal with air pressure. Can't just forget about it. I know sometimes it's nice when you think about, well, I don't really understand it, so I will ignore it.
That always works.
Yeah. Let's see. If air pressure is too low, well, what's the air pressure there to do?
Move to feather.
Assistant
It's not an accumulator. It's an assist. So what's it assist it in doing? Goes a high pitch feather. So air pressure is too low. May not feather. Or it may surge. Back and forth. It's not balanced out right. If air pressure is too high, what's going to happen?
It's going to constantly feather.
Can't feather.
No, it's going to try feather.
Oh, sorry.
At least you're trying. I like that.
Can't run feather.
It can't unfeather.
50.
Close. May not reach high RPM. Why not?
Because you're
Because if you're fighting with feather.
Too much pressure. It's not letting it go all the way to feather, right? Or may feather. May feather when shut down. Now, right now, I don't know why I do that. We're going to talk about that in a little bit. But, no, we'll talk about it right now since we're right there. What the heck? What causes an aircraft propeller to go into feather? Loss of
Engine power.
oil pressure.
Oil pressure. Yeah.
Loss of oil pressure. What happens to oil pressure when you shut down an engine? And then the prop should, in theory, feather. And now you have to try and start it with it like this. It's very difficult to start an airplane when the prop is like this.
Slapping that air.
So when we drop it again, that was fun. By the way, when I brought it in here, I knew, I wonder how many times I'm going to drop it
You
this
said
year.
you were going to drop it.
I know, okay, good. At least I warned you.
One so far.
I was expecting.
Okay. So to keep it from feathering, you need feathering latches. Let's see, do I have a picture of feathering latches? I don't. Even if I did, it's probably easier to explain it.
Start lock latch. Is that different?
Where? Here?
Start lock
Close.
Oh, yeah, start off latch.
Start lock latch. There we go. Picture's not going to help. Maybe it will. Okay, so the way this works is these latches are going to work off of centrifugal force. We only have one example of a latch, anti-feathering latch, in the stuff I'm going to give you an oral on. There is no information on it. I know how it works. See if you figure out how it works. It is not this style. It is one of those things where, and I'm giving you all the information, you can read the book and try and make it into what the book says, and you'll be 100% wrong. Because I'll just say, well, does it really do that? And you're like, no. But that's what the book says. Well, it's one of those things where just because the book says they're two different things, right? So, got it? All right. The book says this is brown. Is it brown?
No.
No, but don't tell me it's brown just because the book said it is. You got to look at it. All right. So with it, more modern feathering latches work is they work off of a centrifugal force. So when you bring the aircraft RPM back to an idle, I'm going to make up stuff here. No, I can't. I was going to use the picture. When you bring it back to idle, it brings the latches into a range where they start to work. Okay, so we come into an idle, we're going to bring the prop all the way back on its low pitch stops. Because at an idle, what is happening in the governor? No matter what, you're in an idle. Okay? So you're in an idle, and so what's the prop going to do? It's going to do its thing. What if you're in underspeed? What's it going to do? Well, it's going to drain or add oil, but what's the prop going to do?
Not feather low.
It's going to go all the way to its low pitch stop. It's going to go all the way. So the governor, one way or another, no matter what input you forgot with the blue knob, is pretty much going to say, "Hey, you're going too slow. You got to go. Keep going this way." It's going to go all the way to the low pitch stops. Okay, that brings it in range of the locks. So within the hub, then, as the dome moves back or whatever happens, or the blade moves with this mechanism, it will bring all that into alignment at the low pitch stops. And then, as you shut down the engine, the centrifugal, we can think about centrifugal pins, maybe these pins right here, right there in the center, we could think about, because they're spinning around, during a normal higher idle, they're out here by spring pressure, and as you slow down, they're going to come in and grab into a little cradle at the low pitch stop. So prop comes all the way back to low pitch. We'll line up something, and the pins that are being held out by centrifugal force, as we slow down, will lock in there.
It's kind of like the magneto impulse coupler.
Sure, yeah, just exactly. But no, if it works for you, maybe it does. Okay, so there it is, latches in. Well, we don't want that to happen in flight, right? So if something weird would happen in flight, we don't want that to happen, and now we can't feather it. So let's think about during flight. So when you're in flight and you want to feather, number one, prop is not all the way in its low pitch stops. It's usually somewhere out just a little bit. Even if you had no power at all, you're still windmilling faster than an idle because you're flying, right? So it's going to miss that feathering latch. So when you slow it down, the feathering latch is still going to miss. So this can go all the way forward and still feather. That's the best I can do. I'm sorry. I don't have a really good drawing of it. I just was never able to find one. So the feathering latch will not catch anything above idle. So if you try and shut down your aircraft at a high RPM, let's say running at 1500 RPM, and you're like, hey, it's a good place to shut it off, mixture, wham. I've never done that because I don't want to, but I'm pretty sure it'll kind of go into a feather, or at least kind of work its way that way.
You do it on the Microsoft program.
Yeah, but I don't know if it's programmed right or not. And if you guys, well, we got planes stacked in there. Normally this time of year, the first group that's done, we would start running the 310, the Bonanza, or the Skymaster, and I'll take you out one by one, or groups of three, and we'll go out to the run-up area, and I'll run up, wide open throttle. I'll, let you see how the prop works and do all that stuff. The Skymaster is really good for that, and the Bonanza too. But Skymaster will feather, so we can feather stuff. And the nice thing about that is you can run an engine if the generators are working, charge the battery to keep one going. All right, so got that? So all feathering props have to have some sort of feathering latch. Feathering latch keeps the prop from feathering on shutdown. That's important because it's really hard on the starter to start an engine that's feathered. They don't spin fast. And then when you start it, it's an event. It's something you kind of like, yeah, this is going to be weird. It runs rough, it runs weird, and suddenly all of a sudden it's like, whoa, it's smooth. Okay, it finally came all the way through feather, all the way into the low pitch stops, and now we're running good. All right, so if we had too much air pressure in this particular prop, it won't go all the way to its low pitch stops, and it's going to miss the feathering latch. So it may feather when we shut down. It's got to come all the way back to that. All right, questions on this? Because that's kind of all I really have for the Hamilton standard. Well, let me see. Hang on. Hamilton standard. Calling. We did the unfeathering. Let me see. Let me just look here. Go back to my notes. This is all the way in 10. 8, oh, there we go. So it's 10, 11. Let's see. Hamilton standard maintenance. Got that. Multi-McCollum, unfeathering. Hey, we talked about that. Yeah, under 900 RPMs that I wrote for the Macaulay, latches and gauge. That's kind of an idle. Yeah.
So when you said that Macaulay threaded hub's going to be filled with two kinds of...
No, there's something in one of the books that I ran across that Macaulays are usually filled with red dye,
Right.
oil with red dye. There's something I ran across that said, or it could have the spiral vent. Okay, if it's got a vent, then that tells me it's not sealed with oil or it would run out the vent. And that one confused me a little bit. All right, if I have a propeller that does not have an accumulator, how do I unfeather it?
Synchronizing system. Synchronizing starts.
Start it.
Yeah.
So if I'm in flight,
Oh, that's right, yeah.
bring the handle all the way forward. What's the prop going to do? It's not going to do a damn thing
Because it's not spinning.
because it's not spinning, which means the oil pump's not working, which means the governor's not working. Now what am I going to do?
Starter.
Electric starter.
Hit the starter. So when I hit the starter, what does the starter do?
Spin everything.
It starts turning the propeller, which is attached to the crankshaft, which is attached to the oil pump in the back, which is attached to the governor. So it starts the oil pressure. It goes up to the governor. The governor's going, wow, we are really going slow now. So what is it going to do?
Low
Flatten the pitch.
Going to add as much oil as it can up in the front, weakly start pushing on the spring against any oil pressure. And it's all it's got to do is just get it started just a little bit. As soon as it gets it started, what happens? It starts windmilling. Let go of the starter. It'll take care of itself on the rest. Okay, if it's got an accumulator,
I thought you were talking about that.
just bring it out
Yeah.
and
You start with me.
start windmill and go. Like, wow, that was great. You don't need a starter.
Mhm.
So if you don't have an accumulator,
You just-
can you restart a feathered engine if the starter burn up?
No.
No, you cannot. So I recently did an annual on a twin Traveler, so it's a beach aircraft, and went to a flight school, and that was like a big deal for them. Does this have accumulators? Because they're going to be shutting down an engine a lot in flight. What's the more modern type of the Hartzell, the compact or the steel? Compact. Although I want to say that the turbine engines, they use the steel, yeah. All right, so time? All right, good place to end, because tomorrow we can talk about the cool prop. The grandpa prop.
Oh, heck yeah.